home with another video. Today I'm going to discuss with you XRD diffraction, and in that particular topic I'm going to discuss with you peak width or full width half maxima, which we can abbreviate as FWHM. That is how to find out or how to measure full width half maxima of any peak. So let's move on. As you know that XRD, that is X-ray diffraction, is one of the best known characterization techniques for all crystal structures, where D is the interplane or interplanar spacing between the two atoms. And of course, now as the planes are formed, they have different coordinates. For example, if there are four peaks, that means four planes. They will be like D, X, Y, Z. These are the coordinates. That is D1 equals to 1, 0, 0. That is X equals to 1, Y equals to 0, and Z equals to 0. So this we will discuss now further. Here, this is a typical diffractogram that is plotted between intensity in AU and 2 theta degrees, between 2 theta degrees, right? This has been plotted and you can see different diffractograms. They are shown here with different colors so that you can see the different peaks and peak heights. Now, if we are going to expand, as I've just written, expand the graph, we have here 1, 2, 3, 4 peaks, as I've just mentioned earlier, right? So 4 peaks means different, that is 4 planes, different 4 planes, D1, D2, D3, D4. These are 4 different planes, and as plotted between, you can see the intensity and the 2 theta degrees. So it simply corresponds to 4 different planes of the crystal structure, and you can simply now find out the peak width of any one selected peak, and I will tell you how you can do it further, how you are going to bisect it from the middle, and then you are going to further divide it into cut it down, and how you are going to go along. I'll just let you know. Here in this slide I've just written how to find full width half maximum of a zoomed peak, right? FWHM refers to what? Simply calculating diffracting domain size. Now, what is FWHM? That is full width half maximum. It refers to how you are going to calculate length diffracting domain size. Now in this slide, now I am telling you how to find out FWHM, that is full width half maximum of a zoomed peak. Now this is a zoomed peak. You can simply see here, right? You can see here it is plotted between intensity and 2 theta. Out of all those 4 or 5 peaks, I've selected this one peak. Now what you are going to do, we cut this line from the middle. What you are going to do, first of all, do it like this. Divide it into 2 equal halves. We divide it into 2 equal halves, and if you further divide it, you can if you further divide this portion even more, then you can even calculate standard deviation. So now here what we are going to do, we have divided it into 2 equal halves, and again we cut this line from the middle, that is here from the middle, right? And this is called a midpoint, right? As if, for example, peak height is 100 centimeters. If this peak height is 100 centimeters, we cut at its half, that is 50 centimeters. And so this is how, and this is what you are going to call this thing. This is full width. This is the full width, right? You will call it a full width, and it is represented by this symbol. By simply cutting it down from here, you will call it a full width, and you are going to measure this width. You will measure it, yes, as I just said, and measure it, and it is called full width. That is denoted by this symbol at half maximum, that is FWHM, as it is at half maximum, and 2 theta is simply a radian. Now here we have a Scherrer equation, and it is used as it connects FWHM, that is full width half maximum, to size of the crystal. The equation is D equals to K lambda beta upon divided by beta cos theta. Now what is K? K is simply a constant. K is simply a. So as I was just telling you, now this is a Scherrer's equation, and simply it is used as it connects, that is full width half maximum to size of the crystal. That is the equation now is D equals to K lambda over beta cos theta. Now what is K? K is a constant. Lambda of course is a wavelength of the incident X-rays. The X-rays that are emerging, incident X-rays, right? D is the crystallite size, the size of the crystal, the crystallite size. Beta equals to FWHM, that is full width, half maximum. And theta is the angle, that is diffracted Bragg angle. This is called a diffracted Bragg's angle. Beta is simply called what angle? That is diffracted Bragg angle. You can see it, as it simply allows to know what crystal's size is, that is a nanoscale range. And if the size is a little bit bigger, that is if it's of a grain size, if grain size is bigger, that is in microns, that is micrometer, you can see here microns, we will have a broader peak. Peak would be a little bit more broader, right? It would be more broader like this. It will be a broader peak, and for that we use FESEM, HRTEM to analyze that grain. So this was a short video to explain you how you can measure the width of a zoomed peak, and what you call it, and that is called, how you can calculate or measure full width half maxima, that is FWHM, how to measure FWHM. So I hope you like this video today, in which now you learn to measure a zoomed peak, and of course you know now how to use Scherrer's equation to connect to FWHM to the crystallite size. I hope you like this video, and you will learn more you will get knowledge from other. You will compare these slides with your own books, and then try to memorize, try to learn more about this topic, that how you can measure FWHM. Thank you very much. I'm Professor Dr. Mchem from Dr.Mchem Institute of Chemistry, University of St. John, Scherrer. Thank you very much.